Hi and welcome to week 21 of Statistics 1 Maintenance, Cambridge Maintenance. Again this week we'll be looking at past exam questions from different parts of the curriculum that we've already covered. The first one, as usual, is representation of data. Okay, so we've got 120 people who are asked to read an article in a newspaper. The times taken to the nearest second by the people to read the article are summarised in the table. Okay, so we've got a grouped table here, 1 to 25, 26 to 30, lovely. Okay, calculate estimates of the mean and the standard deviation of the reading times. Okay, so probably what I'm going to do is I'm going to add the mid-interval value for the times. So halfway, 25 plus 1 is 26, divide by 2. So this is 13. 26 plus 35, divide by 2. So this is 30.5. Oopsie. The next one, 40.5. Oh, this is nice. Next one, 50. What's your writing? 50.5, and the next one's 73. Now, if we're going to find the mean, this is going to be 13 times 4, so the mid-interval value times 4, plus the next mid-interval value times the frequency, so that's 30.5 times 24, plus the next mid-interval value, which is 40.5, and we're multiplying that by the frequency, which is 38, and the next one is 50.5, multiply that by its frequency, which is 34. Last one is 73, and we multiply that by 20. And we're going to divide by the total number, which is this 120 business that we've got there. Now, when I chucked that into the calculator earlier, I got 45.8 to 3 figures. Now, the standard deviation is going to be the square root of, we're going to have a big long thing here. And we'll have, what have we got? I guess 4 times 13 squared plus 24 times 30.5 squared plus 38 times 40.5 squared plus 34 times 50.5 squared plus 20 times 73 squared. I'm going to pop that all over the 120 we have, and then I'm going to subtract the mean, and I'll probably use my unrounded mean squared. That will give us the standard deviation, which is, when I worked it out, I got 14.9 for that. Okie dokie. Next one, discrete random variables. Now we've got this box containing 5 disks, and they've got these different numbers here. And he takes 3 disks at random without replacement and notes the numbers on the disks. Find the probability that the numbers on the 3 disks are 2 even numbers and 1 odd number. Okay, so the ways you can do this, obviously you can go odd, even, even, or you could go even, odd, even, or perhaps even you could you could go even, even, odd. Now, what is the chance of these? Well, so the first one is going to be what's an odd? So we've got odd and odd. The rest of them even. So odd would be 2/5, and then next one you'll have a 3/4 chance, and then a 2/3 chance, and so that works out to be 5, 20, 60, 60, 6, 12 over 60, which is 1/5, doesn't it? 1/5. Now, what you'll find is all of this is also going to be equal to 1/5, and this is also going to be equal to 1/5, because although the numerators will change in order, you'll get the same numerators and same denominators, so it'll end up being the same. end result. So altogether we should have 3/5. Now, that takes us on to the next part where the smallest number of the numbers on the 3 discs taken is denoted by the random variable s. Okay. By listing all possible selections, 1, 2, 6, 2, 4, 6, and so on, draw up a probability distribution table. Okay, so what are the different ways? Okay, so we could go 1, 2, 4, 1, 2, 6, 1, 2, 7. We could go I guess we could go 1, 4, 6. We could go 1, 4, 7, 1, 6, 7. We could start with a 2, 2, 4, 6, 2, 4, 7, 2, 6, 7, 2, 6, 7, and then 4, 6, 7. Okay. So that's 5, choose 3 ways, isn't it? Which is 10. Yep, so we've got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Okay, now, smallest variable. And the probability that s equals s. Okay, so the probability that 1 is our smallest number, probability that 2 is our smallest number, and the probability that 4 is our smallest number. And you can see that 1 is our smallest number in this many options. So that's 6 tenths. And then 2 is the smallest number here, 3 tenths. And 4 and 1 tenth. Now you might be thinking to yourself, what if they were chosen in different orders? Like, you know, for instance, with 1, 2, 4, you could have got 2, 4, 1 or whatever, right? Yeah, well, that still doesn't matter because each of the 3 different ways you can arrange that. 6 different ways you can arrange that. All of them will still have 1 as the lowest number. So all we needed to do is just find the combinations, and then we can determine out of the combinations the probability of 1 being the smallest number, 2 being the smallest number, and 4. And obviously 6 and 7 never will be, because you've always got to choose something other than 6 and 7 with them to get 3 discs taken. So I think that should be the answer to that one. Alrighty then, so moving on to probability. What's Nikita doing? Okay, so Nikita's buying a scarf or a handbag. She's buying a birthday present for her mother. Okay, she buys either a scarf with probability 0.3 or a handbag. Okay, so this must be 0.7 then. And the probability that her mother will like the choice of scarf is 0.72. Okay, and therefore that she won't like it is 0.28. The probability that her mother will like the choice of handbag is x, and therefore the probability she doesn't like it will be 1 minus x. The information, okay, this is a la la la. The probability that Nikita's mother likes the present that Nikita buys is 0.783. So which branches give her a like? So this one, so this branch, and this branch. So in other words, 0.3 times 0.72 plus 0.7 times x equals 0.783. And well, this gives us x is equal to, so I guess we'd go 0.783 minus 0.3 times 0.72, and we're going to divide that by 0.7, so I'm getting 81 hundredths, or 0.81. So I can check that in there, 0.81. Given that Nikita's mother does not like a present, find the probability that the present is a scarf. Okay, so probability that we have a scarf given dislike. Okay, dislike. So this is equal to the probability of the scarf being given and disliking the gift, all over the total probability of dislike. Now the probability of scarf and dislike, so probability of scarf and dislike is this branch here. So that's going to be 0.3 times 0.28. Now the probability of not liking is this branch and this branch. So that would be 0.3 times 0.28 plus 0.7 times 0.19. I'm getting the 19 by taking away 0.81 from 1. Okay, so what does this give us? Typing it into the calculator, I'm getting 12 over 31. Alrighty. Permutation. Oh, this is like one we did in class a while ago. Find the number of different ways the 7 letters of the word bananas can be arranged. If the first letter is an N and the last letter is a B. Okay, so how many? 7 letters. Okay, so we've got N, 1, 2, 3, 4, 5, and then we've got B. Now let's just have a look. That means we've got rid of this and we've got rid of this, leaving us with A-A-N-A-S. So you can see that there's 5 letters, so 5 factorial. However, out of these 5 letters, we've got 3 A's. So they all double up. So it should be 5 factorial divided by 3 factorial, and this gives us a value of 20. 5 times 4. If all the A's are next to each other, so let's go back to bananas. Here's bananas. B, and I'll move the A's to the N. B, then we'll have N, N, S, A, A, A. Now we'll treat this like one group. Okay, so we've got therefore like 5 things we're arranging. So we go 5 factorial, and the A's, it doesn't matter which way they're arranged because they're all exactly the same, so we can ignore that. But these 2 N's we're going to have to divide by 2 factorial, because when they swap around with each other, it makes no difference to the arrangement. So 5 factorial divided by 2 factorial is 5 times 4 times 3, which is actually 60. Find the number of ways of selecting a group of 9 people from 14 if 2 particular people cannot both be in the group together. Perhaps they don't get on. Okay, so I've got person, we've got like person 1, another one here, and then we've got 12 people. So here's the way you can do it. You can choose this one, and that would be, then you've got to get the rest of the 9 people from the other one. So it would be 12, choose 8, right? Plus, now, let's say you choose this Larry instead. Then you'd also have 12, choose 8. And I guess you could probably go, you could just choose everyone from here. So I guess that would be 12, choose 9. And that should be it. Now when we do that, we're getting 1,210. Alright, next one, discrete random variables, the binomial distribution. In certain mountainous regions in winter, the probability of more than 20 centimetres of snow falling on any particular day is 0.21. Find the probability that in any 7-day period in winter, fewer than 5 days have more than 20. Okay, so what we're going to do is we're going to do 1, take away the probability of 5, 6, and 7, right? And that's going to be 1, take away. Now, what's the probability of 5 days? That's 7, choose 5 successes, and the probability of snow falling to more than 20 is 0.21. We're going to do that to the power of 5, and there must be 2 days where we don't get that, so it'll be 0.79 probability of failure to squared. Now, if it's 6 days, it's 726 multiplied by 0.21 to the power of 6 times 0.79 to the power of 1. Now, if we have all 7 days having that much snow, it'll be 727 times 0.21 to the power of 7 times 0.79 to the power of 0. And chucking that all into the old calculator, I was getting 0.994. Hopefully that's right. Last part of today's work. For 4 randomly chosen 7-day periods, and want to find the probability that exactly 3 of these periods will have at least one day with more than 20 centimetres of snow falling. Well, let's just think of one period. Right? So, to find one day, at least one day, that would mean 1, take away the probability of 0 days, which is 1 take away, and then we go 7 choose 0 times, and would have the 0.21, we're going to get 0 of them, times 0.79 to the power of 7, and this gives us 0.808. That's the probability of a week with at least one day or more, at least one day of more than 20 centimetres of snow falling. Now we want to do exactly 3 out of 4 periods. So we have 4, we're going to go choose 3 times, now the chance of having one week of at least one day is 0.808. We're going to do that to the power of 3 because we want exactly 3, and then we're going to times that by the chance of failure, so that 1 week of failure would be 0.192 to the power of 1. Chucking this into our calculator, it's 0.405, and we are done. Alright, hope that's been helpful, team. Let me know if there's any problems with the video, any questions you have. Take care.